Well, folks, now that we have our recording bot and also Dave and all of our guests here, I'm going to start the event as well. And it's time to get started. Welcome, everyone, to this week's incredibly prestigious community call. This one is going to be even better than the previous ones, which I know it's really, really hard to believe at this point because it's already a very prestigious event, but it's going to be even better. Ismail almost brought us elevator music this time. Almost, not quite, but he tried. So let's give him some props for that. If you have any questions or comments throughout the community call, you can leave them in the chat, which we're going to be reading, and we're going to be answering the questions at the end. But for now, let's get started with a quick news roundup. No, actually, first, let me introduce everyone. So Ismail is with me, my usual partner in crime for these community calls.
Hello,
Say hi
everyone.
to the people, Ismail.
It's nice to be back.
It's nice to have you back. And also myself, I am Sudo, aka Simon. I'm head of community for NIM and your host for today. Hello, guys. And our special guest for today, as you know, is co-founder of NIM and also CTO, Dave. Say hi to the people,
Hi there,
Dave.
everybody. Hi, how you doing?
It's awesome to have you on.
Thanks, man.
All right. So moving on to the news roundup. It's going to be fast. What do you have for us, Ismail?
Yes. So NIM CEO Harry Halpin is scheduled to speak on the Web3 privacy panel on December 15th, which is next Thursday. It's a secret network panel and also their first digital event ever. So if you want to attend, there is no need at all to book a plane ticket, luckily, because it's a digital event. So NIM is good friends with Secret Network, which is also a fellow founding member of the Universal Privacy Alliance, aka UPA. So there's still time to register for the event before the 15th. So a link has been shared in the community call text channel. Please make sure to register ahead in time so they know how many people will be there and have fun as well on the 15th. Moving on, you may have noticed that the Shipyard Developer Grants registration period is closed. So it closed yesterday. And just a small roundup for people who missed it or who are unsure about what these things are exactly. So there were two developer grants. These developer grants were, first of all, to build out proof of concept ideas, and the second one was to integrate NIM into their existing application. So there's a link that has been shared in the chat. Please take your time to go through it, so you will have more of a nicer overview of what is going on exactly with the grants. Next, the new NIM mix nodes have been launched in Argentina, Mexico, and Uganda. So please take a look at the NIM Network Explorer as well. It's the official Explorer. So now you'll be more up to date on the distribution of the different nodes around the world. Moving on to you, Simon.
Thanks, Ismail. So, as many of you know, because many of you are actual Shipyard Academy participants, Stage 3 of Shipyard Academy has kicked off recently. So congratulations, first of all, to all of our navigators. There's about 300 of you, and it's really, really good job on completing all the quizzes and making it this far. And the fun fact is that less than 10% of you guys made it this far, which is absolutely huge. So you are already the cream of the crop. It's something to be proud of. Now, one thing that I would like to point out is that there are some user ID mismatches in the leaderboard. That is because sometimes the quiz bot that we're using for the quizzes is showing your user ID, and like some characters are missing or something like that. And for that reason, some of you may be missing, or some of your scores may be missing from the leaderboard. So if that's the case, then make sure to reach out to Gustavo, our good friend and Spanish-speaking community manager, and he will look into it and fix it for you. And also for some people who submitted links to Shipyard using the Shipyard Academy submission form, some of you are not showing up in the leaderboard for the same reason. So if that's the case, then also make sure to reach out to Gustavo, and he will look into it and fix it for you. Now, the same task, so submissions for submissions of content and also spreading the word about NIM and our vision and our products is still going for Stage 3 as well. So keep the awesome posts and content coming, and there is going to be another form very similar to the Stage 2 form, where you can submit your tweets and blog posts and all of the rest. We've seen some really, really awesome content so far. And the prize pool of Stage 3 is once again in your hands. So the minimum of it is 30,000 NIM tokens, and it goes all the way up to 55,000 if certain tasks, common tasks and common goals are completed. So get to it, guys. You still have more than a week to complete them. And more details can be read. I'm not sure where Farnoosh is sharing the links this time around. I think, yeah, he's using the community call text channel. So you can find a link to the Shipyard Academy welcome blog post, where you can find further info about Shipyard Academy Stage 3 in the dedicated community call text channel. And yeah, so a quick note for our Ninja candidates. Like I pointed out in the blog post as well, this is your time to shine. So now there are much fewer participants, and we are keeping a close eye on what you guys are doing, and we're looking for exceptional participants. So although not all tasks that we outlined for Shipyard Academy Stage 3 are mandatory, but the extra ones are there for, so that you guys can show off that you can contribute meaningfully to the project. And also one more quick note on the lecture that we had, the amazing lecture with Jaya yesterday about the big picture of privacy, will be uploaded to the usual playlist tomorrow probably, because I still need to edit the video. And on to our next news item, the next version, so version 1.1.2 of NIM Connect and the NIM platform binaries has dropped. So the blog post to this one was shared in the community call text channel as well. So one thing I would like to ask you guys to continue doing, please test out the new release of NIM Connect and continue to let us know about any issues you may be facing. So the new version has or is supposed to fix some of the problems that you guys were facing. But if you are still having some issues connecting, or the connection is slow, or anything in between, or you have feature requests, please make sure to use the Dino form that was shared in the text channel. That's our feedback form, and we really appreciate your feedback. Now, the other thing when it comes to the NIM platform binaries that is new, of course, there are many other new things as well, but I'm not going to list them all because you can read the changelog for those. But the other kind of important thing, which is a really big deal for the project, is initial support for ZK NIMs. So initial functionality of initial ZK NIM functionality is now supported by the new platform binaries, which leads us very nicely into our conversation with Dave, actually. So let's move on to that. First of all, this is your first time on the community call, Dave. It is absolutely awesome to have you here. Please introduce yourself to those who may not know you.
Sure. Okay. Hi, I'm Dave. I'm from Canada. Live in London, and I'm an old man developer, basically. I've been writing code for a couple of decades now. Previously, I had a software company in London that I sold, and then founded a blockchain company called Chainspace in 2018, based on ideas that myself and my friend George had been working on for a few years as a sort of non-professional but fun project. So we were working on actually blockchain scalability problems from about 2015 to 2018. And came up with a novel way of sharding blockchains to accomplish something like what IBC currently accomplishes for the Cosmos ecosystem. But this was way before IBC existed. So we were thinking of it as a way basically to have multiple shards of execution for blockchains to expand their scalability. We also designed and built later on a very, very speedy consensus protocol called Blockmania, which in the crypto winter of 2018, the last one, actually led to our acquisition by Facebook. So they basically grabbed us, and we became the core of the Libra research and development team. I then decided, I'm not much of a big organization person, and I'm not a big Facebook fan, and I decided I'd rather not work there. So I didn't do that, and I basically at that point founded NIM with Harry and Claudia and the rest. So that's a very quick history. I'm a coder. I'm not just a sort of shirt sleeves or like a CTO who wears a tie and tells other people what to do. I like to always stay involved and code things. And yeah, I guess that's a quick intro to me, I suppose.
And how long did you last at Libra?
About a week. I just couldn't handle it. It was really interesting to see inside one of the big internet companies like that, because I've never had that view of the world before. So it was really, really interesting to see how they operate, to see the total lack of regard for privacy as well that they have was quite amazing too. So
Yeah, I mean, we're talking about Facebook here, right? So
yeah,
that's not a
it's the
shocking
worst of the
surprise.
worst. I know the thing is, if I had stayed there, I would have wanted. If the project had succeeded, I probably would have wanted to kill myself. So it was kind of like not a good place to work. Probably like if success equals death, then you probably have to think about working in a different place. I'm extremely happy at NIM. It should be said.
Yeah, me too. But yeah, so if success equals death, that's probably suboptimal. I agree with that on you.
Yeah, it's not right. Yeah.
All right, so maybe let's move on to talk a bit about ZK NIMS, which is kind of a big
Sure.
deal, right? Let's
Okay.
let's turn on your camera contraption
All right.
device
Let's
thing.
try that first. Oh, video chat is not available for more than 25 users. Well, we failed at the first hurdle,
Oh
Simon.
no.
That's all right. It doesn't matter. We'll just talk about it in a more abstract way. So everybody, Simon and I had a plan. We were going to actually have me draw things out and draw the system out just to make it easier for people to understand. Because sometimes if it's just somebody's voice droning on about the technical subjects, it can be quite difficult to understand things. But we'll go at it without the video capabilities that we thought we would have, I guess. Cool. So I guess yeah, let's talk sort of. I'll just do a kind of introduction to what it is that we've built and how we're going to roll it out because I think that's the there's sort of two parts to this. So first off, let's talk about NIM generally for just a second. Probably a lot of people who have experience of NIM and the system so far think of NIM primarily as a mixnet. So a lot of people, even internally in NIM, when they talk about NIM, they go, "Oh well, NIM's a mixnet." And they're right. There's a mixnet in there, but for me, my perspective on things is slightly different. I think of NIM as a project, not as like a single technology, and it's a project that actually is going to have an increasing number of components or kind of tricks in its goodie bag as time goes by. So the mixnet was the first one, but we're planning to snap together a much larger system that protects privacy in multiple ways and expands the sort of range of useful things that you can do with the system over time. So the mixnet was the first one. The second one that we're dropping is this thing called ZK NIMS. Now, what is that? Well, the mixnet's job is to protect you when it comes to network privacy. So it is designed to ensure that no one can eavesdrop on your communications or even tell who you're talking to. That's the kind of privacy guarantees that the mixnet can give you. It's worth saying in the context of the mixnet, we'll be releasing some pretty major upgrades to the mixnet over the next few weeks, but that's not what this call is about. But you can look forward to something called single-use reply blocks working in a much better way for quite soon. So this thing called SERBs, not the nationality, but the technology, will be in the mixnet. Yeah.
Some of the audience actually probably knows about SERBs because I had Simon Wiki on twice so far, and we talked about
Okay.
SERBs extensively, and
Cool.
also the dual SERBs, was that a thing?
Yeah. So we're basically. So we use serves for a bunch of things already, but in the next 1.2.0 release, which should be either next week or the week after, depending how the QA of it goes, we'll be releasing serves for general usage. So you'll be able to have arbitrarily sized replies, and this will make it a much more useful privacy system. Basically, it's something we've wanted to do for a while, just hadn't gotten to yet. But so we're really excited about that. So. Anyways, I don't want to focus on the mixnet too much just because there's lots of other stuff to talk about, but that's a worthwhile thing that's coming. We also are working on major performance and stability improvements as well. So you'll see a bunch of stuff in the context
Hey, Dave,
of yeah.
Let me stop you for a second. Sorry to interrupt,
Sure.
but I just got some info on how we may be able to fix the camera issue. So
Oh
if you
yeah.
don't
Okay.
if you don't share your camera but you share your screen, that
Oh really?
works with more than 25 people as well. So if you can bring up the camera view that you would be sharing otherwise, and then share your screen while doing that, then we will be able to see it.
All
Does that
right.
work?
Yeah. Well, let's see. It says I have to open my system preferences and grant access to something. Add an application, click the lock to make changes. 1 second. All gonna happen. Bang, bang.
Believe me, guys, it's absolutely worth it. Dave is really good at illustrating things.
Well, I'm not much of an artist, but it does help me think things through when I'm doing it. So 1 second. Cool. Bang, bang. Oh, Discord will not be able to record the contents of your screen until it is quit. All right. I guess I don't know if I should do this. All right. Cool. 1 sec. Okay. Am I back?
Let's see. I can't see you stream yet. You are back.
Okay.
I can hear you.
Okay, that's good. That's already a win. What should I share? I guess is my question.
If you can bring up a window, something that views your camera,
Yeah.
the one
Okay.
that
Cool.
you would be sharing, and then share
Yeah,
that.
I'll just do that. Good idea. I'm going to go into. Great, and cool. I'll just share this guy. That'll be cool. How about that? Does that do anything? Can you see a human hand come into the photo? Yeah. All right, cool. Good. Well,
Yes, very much so. Awesome.
Looks
That's
good.
pretty cool. All right. So yeah, this kind of thing helps me think, guys. So good. Thanks for the tech tips there. That's pretty handy. So yeah. So let's think about the whole system as it stands right now. We've got people probably think of NIM as being this mixnet thing. So it's like this is how I draw it typically. There's like mixed node, mixed node, mixed node. Two rows of three. We have a gateway here. We have Timmy, our user.
How come it's not
And
Ellis?
Timmy has some kind of client, and he connects to the gateway, and then through the mixnet and out to the big world. Yeah, and if we want to affect things in the world rather than just route messages to each other, which we can do, then we have this notion of something called a service provider, which can take action on people's behalf in the outside world. So that's when people talk about NIM. That's typically what they think of what NIM is. I would guess. I see NIM as I was saying, as a wider collection of technologies. And then the next one that we're releasing has just come out in version 1.1.2 of the platform that we've just released. So what is it? It's something called ZK NIMS. I'm sorry that I have terrible childlike handwriting, but I'm using this Sharpie and I'm not exactly a neat person anyway. So, yeah. Oh, really? Let me see if I can fix that. 1 second. Yeah, you're right. That is a very good point, and I think that is fixable in here. Settings, maybe settings. Profile devices. Yeah. No, I think it's something that Jitsi does actually, and that's what I'm using to. Man, is that ever annoying? Maybe I can. 1 second.
Live troubleshooting, folks.
Yeah, it's pretty exciting. Oh man. I don't know, man. Let's just ignore the fact that I've written something, and I think it's as long as I stick with just basic shapes, I think everything is probably going to be just fine. So let's just stick with this thing for the moment. Cool. So right. So this other thing that we want to release is something called ZK NIMS. Trust me that it exists and that we don't have to write it out, and then everything should be cool. So the basics of ZK NIMS is it's what we call a signing protocol, or it's like a signing scheme. So a signing scheme is Something that allows you, like let's say a public key cryptography scheme that you can say, okay, I want to have three functions. I have a key generation function, so I can make a public-private key pair, and I can sign messages with the public part of the key pair, and I can verify messages. Sorry, I can sign messages with the private part of the key pair, and I can verify messages with the public part of the key pair. So everybody, I think, should be, most people are pretty familiar with that as a kind of notion. Does that make sense? First off, Simon, you've heard of this kind of stuff before?
Yes.
Okay,
Definitely.
cool. So good. So, what is it that we've produced? Well, we've produced one of those basically. It's a new signing scheme. It's a signing scheme that's based on again the work of my buddy George, who has a hand in almost every technology that NIM currently produces. Including the Sphinx packet format, the Lupix mixnet, and additions to it, as well as this thing called Coconut, which is the basis of the ZK-NIMS signing scheme. So the things that we add to a basic signing scheme that turn it into this really interesting signing scheme that can be used here is essentially a couple of things. The first, and the kind of zero knowledge part, I'm going to try to write a Z backwards. I don't know. That's probably isn't right. Oh, it is. KZ though. Anyways, think of that going backwards, and you would basically be in the right spot. So we have this zero knowledge proof capability built into this signing scheme. What that zero knowledge proof is for is it protects the person requesting a signature against the issuing authority. So who is the issuing authority first? And what does this whole thing look like in terms of here? So right now, this is the mixnet, let's say, over here. The other half of our system, I'm going to get back to the signing scheme in a second, but first you can see where it lives. We have these validators that are all validating the blockchain. And typically when I like to draw the kind of validator part of this thing, I draw them as these kind of ring of circles, and they're all exchanging messages. They're exchanging transactions with each other to sign those things and to come to consensus on what the order of transaction was, and then basically they make a blockchain. And the blockchain is, let's say, this database thing that they all collaborate on making in the middle. The reason we have to have this blockchain over here for the mixnet is because we want users to be able to ask the validators which of these nodes are in the mixnet, which can I actually trust, because that would be a pretty weak system if you didn't have some guarantee that the mixed nodes you're sending your traffic through was actually validated by anybody or was like included in the list for a reason, right? So that's what we've been using the blockchain for thus far. We're going to expand that, so we're going to add an extra little bit to each of the validators on here, such that each of these validators will be able to collaborate to produce what are called ZK-NIMS, or in the old world parlance, coconut credentials. So this is the coconut credentials scheme. A credential is sort of like cash is a credential in the real world. Let's just think about sort of an easy way to explain this. A $5 US note, like a bill, is a kind of bearer token or a credential in some way. It gives you access to resources. Yeah. So you can walk into a store and you can say, "Hey, I'd like to buy a can of Coca-Cola," and you can give them $5 and they'll give you some change back, and they'll let you take the can of Coca-Cola. So in that sense, cash is an entitlement to something. Yeah. So it allows you to do things. And the other interesting thing about cash is that it can be, it's like basically verifiable by a normal person who's behind the bar, well, you can say I've been drinking too much, behind the convenience store counter, and so it has a kind of verifiable, provable property that the person can like look at it and go, yeah, that looks like a real one, and it also can be exchanged among people without any kind of trace, basically. So I could give you, Simon, a $5 note, and you could go buy something if you wanted to. Cool. So like
Dave, I'm pretty broke right now.
Yeah, cool. Yeah, I'll get to that then. Yeah, so these are the properties that cash gives you. And so we can call cash, a $5 bill, is a kind of bearer token. Okay, so in the same way, these coconut credentials that we're talking about are the validators can collaborate to produce these bearer tokens, and the bearer tokens can be then redeemed, and they can be passed around between people, between organizations, between smart contracts, and they can then be redeemed for or validated, verified by anybody who has the public key of the credential producing system. Does that sort of, we'll talk about what it can do practically in a second, but you can basically, does that idea of what a bearer token is, does that make sense? It's a, in the real world, it might be like a, I don't know, lottery ticket or a $5 bill, stuff like that. In the cryptographic world, it's basically any message or chunk of bytes that you can verify that can give you access to something. Does that make sense? Or do you have any questions about that, Simon?
So it makes total sense. I can't see any questions regarding this, but I'll look around in chats.
Okay,
a second.
Cool.
Yep, no questions.
Okay, cool. So Timmy over here will be able to go, hey guys, so what is the first thing that we're planning to use this system for? What role does it play in the NIM system? Well, right now, all the gateways are wide open. They are currently, they just go like, cool, Timmy wants to connect, Timmy can connect, and he can send his traffic through the mixnet. We're going to make next year, and we don't have a schedule for it right now, but during the course of next year, we will at some point start to have gateways that can actually charge for access. And we would expect those gateways to be, people are going to expect that they're much more reliable and that they maybe have more or higher machine spec and all of that kind of stuff, and they'll be willing to pay for that. Basically, that's part of the sort of value proposition of NIM. So what we're planning to do is to allow Timmy to go to the blockchain and go, cool, hey, I'm gonna transfer some of my NIMs into the bandwidth buying contract, and the system can then go like, cool, hey, Timmy can then ask for a coconut credential back from all of these validators, right? So all of these validators can collaborate to give Timmy his bearer token, which can come back to him, and then he can send that to a gateway as a means of privacy preserving payment, basically. Because that bearer token will be, let's say he transfers, I don't know, 10 NIMs into the contract. He'll get back some amount of bandwidth from a gateway. He'll take that bearer token to the gateway. He'll say, hey, gateway, this bearer token that I'm giving you should entitle me to, I don't know, a gigabyte of bandwidth, something like that. So it's basically what we're providing is, as the first kind of test bed demonstrator of these ZK NIMs, is the ability to buy bandwidth and then redeem that bandwidth at gateways. So that's the first role that the credentials play. Does that make sense?
Makes total sense.
Okay, cool. Good. So that's what we've released this week. Now, that doesn't mean that it does that job this week, because nobody's running the code. So we are in the process right now. We're reconstituting the sandbox testnet that we had up earlier this year. And we're rebuilding that with all the latest versions of everything. And we will have a sort of technology demonstrator of the bandwidth purchase process, the ZK NIM redemption process, all of that kind of stuff, just so people can see the technology working and start to experiment with it. And later on, now, because it's getting very close to Christmas, I have a feeling that we'll fall afoul of the Christmas period, but I would expect that early in the new year, we're going to be rolling this technology out. We have to talk to the validators and start getting them to run these new components. And then we'll have this major new capability within the kind of ecosystem. At first, our plan is just to focus on this one use case of bandwidth buying. But there's nothing to say that we can't, and this is where it gets really exciting for me. So I'm a general purpose programmer. I like to make lots of different stuff, and what we've built here is not sort of only for the use of the NIM application itself. So we could have coded it in such a way that all of this stuff was really only for NIM, and all you could do was these things that I just talked about. So this is where things are going to get really exciting next year, I think. So the way we've built NIM might not be apparent to people, but instead of doing what would have been when we started the project, the normal Cosmos thing of you make a one application per blockchain kind of thing, we had the option to do it that way, to code all of the stuff that runs the Mixnet directory. We could have built it straight into the validators, coded it in Go, and that would have meant that we only had the ability to have one application as NIM in this whole system. But I made a somewhat crazy at the time technical decision, because there was something called CosmWasm, which is a smart contract framework that became available right around the time that we were starting to work on the putting the directory into the validators. So I made this crazy decision because CosmWasm at the time was probably best described as neonatal. It was like very, very young, and we're probably one of the projects that has used CosmWasm now for the longest because of this decision that we took. So we built the entire sort of thing that runs the Mixnet, the entire blockchain part of that, not right into the validators, but as a smart contract. At the time, I did that mostly because I wanted to be able to develop things quickly, so we could get this project going and have it working really quickly. And part of that is that you want to be able to release things really, really quickly. The difficulty with projects that build their stuff directly into the validators is every time you want to deploy any code, you have to coordinate, potentially however many validators you have. I mean, maybe there's 50 of them, maybe there's 100, maybe there's 25. It's a lot of organizational overhead, and it slows projects down. So at first, part of the value that I saw in using CosmWasm was to just allow us to re-upload the contract when we wanted to during development, and iterate rapidly on the contracts. So that worked out super well. What it gives us now is, okay, we have this system of this zk-NIM system that we can use to make these bearer tokens. The first bearer token that we've made is for our own purposes, is for doing bandwidth credentials. But because we wrote this entire system as smart contracts, that means that next year we can actually open up the whole system so that other people can use the same smart contract capability that we use to make NIM. And other people can potentially use this zk-NIM system to make other applications that they think up that are like their own thing. So basically, we're going to open up like an arbitrary smart contract construction process for that people can upload their smart contracts, sort of like what Juno does. But at the same time, you'll be able to use the coconut or the zk-NIM, these little dots here, aspect of the system that we've just released last week, or sorry, 2 days ago, and basically use these extra privacy features. So what could you do with that? Well, you could, for example, build anonymous governance platforms. You could build anonymous voting platforms. You could have forms of private payment if you wanted to do so. And so there's a whole interesting set of privacy-friendly applications that NIM can really start to enable for a wider group than just ourselves. So that's something that I find really exciting, and that's why we make this distinction between the NIM privacy system itself and the Nix blockchain. So they're slightly separate projects by this point. And we should see Nix turning into something a bit more independent next year. Does that make sense as a kind of First, does it make sense, the kind of bandwidth credential part? And then does it make sense that to everyone that it's possible that other people can also use this base technology that we've built to enable their own applications?
Yes, I think it makes total sense. And also it's great that you explained it, because in the past year or so, we've been, of course, focused very much in our communications on NIM, and mixed nodes and mixing and the network infrastructure part. And we kind of neglected the fact that NIM itself is just, as a system, is just a use case. The NIM smart contract is just a use case of the Nix blockchain, right? So it's really nice that you made this distinction.
Yeah, so it's a bit of a we've done things a little bit backwards, I guess you could say. If you think of this setup is sort of like in the Ethereum world. Ethereum is the base blockchain, which they of course built first because they're not doing things in the way that we've done this, and then other applications are built on top of Ethereum. What we've done is basically started by building this privacy system, which then incidentally needed to use a blockchain for its directory, and now we're going to launch the actually underlying blockchain. So that's what's going to happen next year. As far as the zkNIM stuff goes, they're in a state right now that they are usable. That is, we could. I mean, I wouldn't want to launch it directly into production tomorrow morning or something like that, but it's in a very usable state from a cryptographic point of view. There's a few things that still need to be built to make it more flexible for the longer term. So we're still working on certain aspects of things, mainly to do with distributed key generation between these different nodes. Right now, we can set up a bunch of them, but then we can't have any new nodes enter or any old nodes leave. So we have to do the key regeneration part of that. So that's the next big piece of work there.
Can you explain that a bit in a bit more detail?
Sure.
What that means exactly?
Yeah. I can do that. 1 second. Let me just try. Let's waste a couple pages here. All right. So we want to make this. We want to be able to assign something. And again, we have these validators. Cool. And we're running the signing code on each of those. Yeah. Great. The question is, what do they sign with? So they have to, in order to have a kind of a public key cryptography scheme, there has to be a key that's a private key that does the signing of stuff. And there has to be a public key that you can give to anybody, and then they can use that to verify any signature produced by the system, right? So the validators are able to make a coconut credential and say, this person put 10 NIMs into a contract, because they can easily see that, themselves, because they are the validators. It's actually really easy for them to verify that for to their own satisfaction that they can, that an event has occurred that is like, okay, Timmy put 10 NIMs into a smart contract. Great, they know that. That's great. They can say yes or no, that happened. Then their job would be, cool, we're going to then make this credential thing and we're going to give it back to the user. Now the question is, what private key are they signing that credential with? That's a big part of the Coconut system, is basically that it's what's called a threshold signing system. So you basically could have, let's say we said the threshold was more than 2/3 of power must sign. Then if any 4 of these 5 sign a credential, then the credential is a valid credential, basically. The question is, so these guys are signing, they're signing with their own, this guy has, like, let's say his key is A, his key is B, his part C, D. I realize this is backwards, but just assume that these are like letters. If we then combine, like, the full key then would be A, B, C, D, E, right? So we could sign with 4 of any of those 5 letters, and we would be cool if we produced a signature. The question is, how do these guys generate this master key together? The master key is, in this case, A, B, C, D, E. Okay, so it's this thing that they all sort of contribute to, and they each have a piece, let's say, of a longer master key, and 4 to 5 in this case of any of these letters or of any of these keys can do a signing process. So they can use that as their private key to sign. In order to get to that point where they actually have that private key, they need to talk to each other, and they need to go through a process of going like, hey, I've generated some key shares, and I'm going to send those to you guys like this. And then everybody goes, okay, cool, that's it. That's the key material for this validator. That's great. I need to now do something with that and go through a sort of key generation process, and then send some stuff back to that guy. And this person here has to do the same thing. Their validator will go, hey, here's my key material, and send it to the other the others. And basically everybody talks to everybody else. And at the end of this sort of dance that they do together, they each have their piece of the private key and nobody else's piece of the private key. So then they can do this threshold signing process. That part is done, so that works, but it works once at the moment. If we then have, let's say, this guy here goes away, and we have another two people enter, so we have this validator here comes in, and another one over here comes in. Right now, we don't have the facilities to regenerate the key, keeping the previous parts of the keys that everybody else already had, and generating new key shares for these two people here who are coming in, and also getting rid of the key share for the person here who's leaving. So we're basically working on the second phase of this distributed key generation process, which is a key resharing process right now.
See, okay, that's clear. Thank you for explaining it.
Yeah, cool. Great. So yeah, that's the basics of the ZK-NIM system. So anything that a validator can easily attest to, typically anything that can be expressed in a smart contract, validators can then produce these ZK-NIMs for users, and then those can be passed around as bearer tokens, like cash can be passed around. So it's quite a private thing. You can pass it around, and whoever wants to can then use that to present the bearer token for whatever purpose that basically serves. There's one thing that's worth talking about from a programming point of view, which is how to explain this. The ZK part of this thing. So what does that consist of? Well, this is the hardest part of the thing to explain. There's a process during the credential issuing process. There's something called blind signing, and blind signing, what that does is it protects the user who is asking for the authorities, these guys, to attest to something. It's not very nice if the user of who's asking any of these guys basically has to reveal his identity or her identity to these authorities and say, hey, it's me, it's Dave, I'm the one who's asking you to make me a bandwidth credential, for example. So what we can do instead is we can actually have a zero knowledge proof that is embedded in the credential request process, which will say, is it the case that this person has submitted some amount of money to the smart contract that you guys can attest to, and is it enough that you could give him this much bandwidth, let's say. That's the way it's kind of expressed right now in the zero knowledge proof. So what that kind of means is that we can check, like, has this person submitted some amount of money to a smart contract? The validators, they don't even know who they're signing for necessarily, and then they can attest to that without knowing the identity of the person who is being asked about, basically. So that protects the user against the issuing authorities, which is a handy property of this whole system. That zero knowledge proof is a very specific construction of a zero knowledge proof, which is basically designed to do that one job and that one job only. So it's worth saying we're not trying here to make, let's say, kind of arbitrary, you construct your own, snap together your own zero knowledge proofs using like a zero knowledge proof language that we're trying to build, anything like that. It's actually super simple to use as a programmer, because it's just a pre-built thing that does exactly one job. Over the course of the coming year or so, we'll be expanding the range of zero knowledge proofs that are available within the ZK-NIMs or the Coconut credentials, such that we can express other interesting ideas as well. So for example, we'll be able to do one that will handle things like know your customer. So you could get a KYC credential, for example, that could say, hey, has this person passed a KYC process? And the authorities will be able to attest yes or no that this has happened. And then you'll have something that you could potentially use as a zero knowledge proof credential that would basically say, cool, this person, and I don't know who it is, has gone through the KYC process. But you don't need to know who they are because the authorities of this KYC provider have attested that they have done it. But beyond that, you don't really need to know their name. So this is the kind of application builds that we want to enable using the ZK-NIM system. It shouldn't really be necessary for most of the systems that you interact with all the time to always know who you are, where you live, what your credit card number is, all of this kind of stuff. We want to enable applications where once you've sort of, I don't know, past the entry barriers of stuff, there should be no reason to leak all that data about yourself all over the place all the time. So we're gonna be adding to the repertoire of zero knowledge proofs within the system so that it goes beyond, did some currency enter a contract, to things like anonymous KYC. It should be possible to express things like voting, for example. So we could say, yes, this is a secret vote. One of the fundamental bases of our normal society, but quite difficult to achieve in blockchain systems. So we could say, yes, 100 people have voted. We can prove using these zero knowledge proofs that 100 people have voted, but we don't know which way any individual person who submitted a vote, which way they voted, because that's not possible to say. We can only say that 100 people voted and the outcome was 53-47, something like that. So that's like that's another kind of thing, another kind of system that we can enable to be built using the ZK-NIMS process. The really nice thing from a programming point of view is zero knowledge proofs are hard. They're like not something, in my view, that normal programmers like really ever want to have to learn about. Having this kind of like having these things embedded within a bearer token like this and this kind of credential generation process means that for normal, lunchbox kind of like application developers that want to just make things without having to go deep down, we can sort of prepackage all these concepts for them, and it becomes something where they go, okay, cool. I need a zero knowledge proof credential that will tell me that somebody controls a NIM address, for example. That's another one that we could build. Or I want an anonymous voting zero knowledge proof. Give me back a credential that will, give me that capability. Or I want one that will prove that somebody has some amount of currency that they control in a smart contract or that they've submitted to a smart contract. Great, give me that one. They don't have to think about how that thing was constructed. They don't have to do the work themselves of trying to snap it all together, because we'll have done that for them. And it'll be like it'll be the difference between going into a restaurant and like them showing you to the kitchen and saying, okay, make your meal. That's the kind of like, that would be the kind of brutal answer to these things. Rather, you go into the restaurant, you sit down, and there's a menu of available things. At first, the menu for us is going to be quite small, but will expand over the course of 2023, the sort of range of zero knowledge proofs that are embeddable within the Coconut credentials. And I have a feeling that there's a finite amount of these things that will enable a lot of applications to be made and a lot of flexibility on the part of programmers without them having to understand the guts of the construction of these things. So our bet is that will be a very popular thing, because it will really enable privacy in a way that other systems can't currently support, and in a way that will be understandable to a large mass of programmers, we think. So it's quite an exciting development in privacy generally. So I'm extremely excited about the whole concept of the ZK-NIMS credentials.
Well, it's an absolute paradigm shift. So so it's hard to overstate how important this is, as opposed to the current system where basically the idea is that I'm going to throw all of this data at you, and with that I verify not only that I let's stick with the KYC example, that I pass KYC, but also who I am, where I live, what my mother's name is, what my social security number is. So just as an overall paradigm in this world, it's going to be an absolutely huge shift. One thing that is a bit blurry for me, if I may ask, before moving on to community questions. So when you say authority, let's stick with the example of a KYC provider using ZK-NIMS. What's the authority like? So they would still hold my data, right? And based on that data, they would verify who I am, and then enable me to get an anonymous credential of me passing KYC, right?
Yeah. That's exactly, yeah. So there's always there if you want to do things in the world, there are typically authorities who are capable to assess that you are like you're able to do thing X, whatever that thing that whatever that might happen to be. So you can't get around that in the case of KYC. There's going to be a KYC provider that is going to check you out. The question is, cool, once you've done that, they don't need to pass any of that information around necessarily to anybody else. They can actually hold it within their own systems, and you can present your, basically private credential to, I don't know. I mean, this is all a bit science fiction at the moment because nobody's ever done this before. So the infrastructure and kind of thinking that people have to support it doesn't exist. But it's illustrative of the kinds of new applications that will be enabled by this technology. You could show up at a coin sale with, here's my KYC credential. This proves, guys, that I have been KYC'd. So, pass me through because this gives me access, basically, and you don't need to know who I am or anything about me. That's the kind of exactly. That's the kind of stuff that can happen there. But there's still, the authorities still exist, but they're decoupled from the presentation of the data of the credential, basically.
It's amazing stuff. I'm super excited about ZK NIMs or coconut
Cool.
credentials in other ways.
Me
All right,
too.
so moving on to some community questions because I'm actually taking. Are you fine going a bit over? Because I think I'm not gonna be able to finish this in 4 minutes.
Yeah, that's fine. Sure. Yeah.
Awesome. All right. So the first question is from Cubonic.
Yeah.
Are there plans for NICs to utilize interchain security with the Cosmos Hub?
Not at present, but I'm watching that pretty closely. I don't think so.
And okay, so moving on to the next question. I think you thoroughly answered this, but I will still ask what the
Yeah, fine.
blockchain does in NIM.
What the blockchain does in NIM. So,
Yes.
so let's go back to the mixnet for a second. So when we think about the mix, this is the first and most important part of what the blockchain does. We didn't stick a blockchain onto the side of this mixnet just because we thought, wow, it would be cool. It would be a fun way to, I don't know, have a really hard to use directory because we could, if we were able to just use a database, that would be great. But we want to make this, so this is what Tor does, for example. And Tor is broadly similar in its aims and in some ways in its architecture. So Tor has like a kind of centralized directory authority, and you could run that kind of system. The difference between NIM and Tor, is that in NIM we want there to be no central point of control of the system. So the system should just run forever. As long as the different components are running and there's a will to keep the thing running, which we think is the goal of decentralization is a good one in this case for this class of system, we think. The second difference, and probably the really important part where we have the blockchain here, is the reason that people run Tor nodes is because they're nice people. They want to provide privacy, network privacy for the world, and that's actually super cool. It's like it's lovely that people want to do that. The difference with NIM is it solves one of the problems that arises from Tor's model, which is there are only a few thousand people who want to run Tor nodes for free forever, and that when there's more demand, Tor cannot just like find more altruistic people and to suddenly run more Tor nodes. The system just starts to grind because actually there's too much usage for the number of nodes that they have, and it can't scale up and down in response to changes in demand. So when there's more demand, what you want to have is a system where, okay, wow, there's incentives, which is what we do in NIM, to add nodes and add capacity to the system. And by the same token, when there's a decrease in demand, actually it's wasteful. It's wasteful of resources. It's wasteful of money to run with too many nodes. So we want the system then to scale down. So the blockchain acts as a kind of directory system, but we could have done that part with a database. Once you have the cryptocurrency part of the system, you can have incentives that will encourage people to run more nodes when they're, you jack up an interest rate in the incentive system, and that gives people more, desire to run more nodes and the system can grow in capacity. And when there's less demand, actually we drop the interest rate. People start shutting their nodes down because they're no longer making money till the kind of demand level stabilizes. And then it goes back to a kind of normal rate. And then we're running with a smaller system again. And that's the basics of why there's this blockchain component to NIM. And it solves that set of problems elegantly. And it's been working so far, which is really, really encouraging to see, actually.
On that note, actually, if anybody's interested in this topic and the economic model that that is enabled by using a blockchain, then make sure to check out Claudia's lecture. I hope someone can find a link and share it in the chat. Maybe Ismail, please, because she explained this in pretty extensive detail. Like how our token economics serve these incentives, and also keeping the mixnet itself secure as well. So making it very expensive for malicious players to run a mixed node. All right. So moving on to the next question. I think you also kind of already answered this, but I will still ask. Would service providers need to implement their own payment identity system?
It's a really interesting question, and I think that the way we deal with service providers in the system right now is severely undercoded. It's severely under thought about. The way I'm thinking that we can like make service providers really happy and actually do some really cool stuff is first, I think we need to make a contract. We'll make a NIM itself. We'll make a smart contract that will be a directory of service providers, so that service providers who want to register in that smart contract can register there and therefore be discoverable. We probably need some way of people of different service provider categories expressing what their capabilities are. So maybe you are a network requester, or maybe you are a service provider that sends transactions to the Ethereum network. There could be a bunch of different things, right? So we want to have some way for people to describe the capabilities of what their service providers are. But once we also have the smart contract system openly available for people to build smart contracts on, I think that what we'll see is, especially as it'll have these ZK NIMs for available as well. What I expect to see, and what I think will be fascinating if it does happen, would be that service providers will be able themselves to define their own additional economic model, by expressing them as a smart contract and then charging for maybe access to whatever service they're actually running. That's one way that it strikes me that we could proceed. That's not 100% solid. This is partly, it's something I'm thinking about. I don't know how exactly it will work, but I have a feeling that would be a desirable direction to go in, and that's what we'll be exploring soon.
Definitely sounds like it to me as well. All right, I think we have a couple more questions. Do you have time for them?
Sure.
All right, let's go. So are these zero-knowledge utilities intended for Cosmos SDK developers, i.e., is composability using IBC very important, or do you expect non-IBC enabled chains to utilize NIM/NIX utilities? This is also from Cubonic, by the way. Sorry, I always forget to call out the names. Sorry, guys.
Oh, that's cool. I guess at first, we're still stabilizing this system, right? And we need to make this thing, how would you say? We're still building this thing. So you can see, for example, that we have to finish off the some essential features of the distributed key generation process. We have to test it out. We have to audit it. So we have quite a bit of work left to do still in this realm to make this thing like fully ready. And then we have to figure out how do we make a really convenient interface to program with these credentials. Right now everything is kind of coded in such a way that it's all geared towards making bandwidth credentials, for instance. So there's quite a bit of like convenience work left to do. There's quite, we want to have more zero knowledge proof constructions, all of this kind of stuff. So the easiest way initially for people to access it from within the Cosmos ecosystem is probably to IBC their way in if they have some stuff that they want to use with the zero knowledge proofs, do their contracts on the NIX blockchain, and run it that way. Having said that, everything we build is 100% open source. If somebody wanted to run their own authorities on a different, their own ZK NIMS authorities on a different blockchain, I can't see any barriers to someone doing that if they have this sort of knowledge and skills to do it. But you would also expect that the sort of, I don't know, the most advanced iteration and probably is always going to be on our blockchain because we're the ones who know how to do this stuff. We have some quite extraordinary people working on this stuff. So Alfredo and Anya are putting a lot of work into this stuff, and they're really rare people actually. So whether you want to run this system on another Cosmos blockchain, there's no technical barriers to you doing that. But whether you really, really want to is, something you'd have to think about probably a little bit before just jumping in.
That note, ladies and gentlemen, a quick comment. So Anya, I'm still trying to get on the community call. She will come on at some point, I promise you that. But we already have a recorded community call with Alfredo where he talks about anonymous cache and also I think coconut credentials. It was a while back, so I can't exactly remember what we talked about, but it was super interesting. So I recommend you guys checking it out. Hopefully someone can find a link for me. And Dave, I think this is going to be our last community question for you.
Yeah.
I'm not sure whether it's a question for you, so please let me know if it isn't. So with the new binary release, node families were introduced. So can you please share a few thoughts on that?
Sure. So we have a mixed net. We have these layers of nodes, right? And our security guarantees hold true if the nodes are run by mutually adversarial people. That is, if you are a mixed node operator and you get like a phone call one day from another mixed node operator saying, "Hey, why don't you collude with me?" Then please let us know so that the whole community can be safer by saying, "Hey, this guy is this guy's a bad person." Basically, he was actually asking me to share details of network traffic that came through my node. That's a very, very bad thing in the mixednet land. Yeah. So we want to be able to enable people who may have large amounts of stake actually to run more than one node because, it could be the case that you have maybe staking capacity to run more than one node, but and it's desirable to do that because nodes have a stake saturation point beyond which it's just stupid to stake on them because you don't get any additional returns and you're wasting capital. So node families are basically a way to say, for honest node operators, to say, "Hey, I am starting this node family," and what that means is these 5 mixed nodes are all in the same quote unquote family. There's a signing process that you go through in order to make that happen. And then the system can now determine, okay, cool, these nodes are all in a family. We are never going to put these nodes in layers, let's say 1, 2, and 3 of our 3-layer mixed node, because then inadvertently or not, like on purpose or not, that operator can then, that organization or that node family could then de-anonymize traffic that went through their nodes, because some fraction of traffic, not very much actually, but some small fraction of traffic actually would go all the way through the three layers that they control if they have, let's say, 5 mixed nodes, right? There's a non-zero chance that they're going to be put into those layers. Node families is basically a way of the directory contract saying, cool, these nodes are in a family. You can put them in layers 1 and 2, but never put them in layers 1, 2, and 3. So then they can't get that kind of view of traffic. So that's one way and this only works for honest operators. We have other ways that we're currently working on, which can start to help dealing with dishonest operators. If you're interested, there's a paper called Sybil Quorum, again by my buddy George, which is a way of doing probabilistic detection of Sybils. That is things like botnets or people who are claiming to be one identity but are claiming to be 5 identities, but they're actually just one person. And we're as an experiment, again in the new year, we'll be releasing something that will allow people to use Sybil Quorum, which is a very, very interesting concept to try to detect people who are running non-honest amounts of nodes that would allow them to de-anonymize traffic within the system. So that's another kind of improvement that we'll be looking at next year. But node families is for honest node operators to be able to run a bunch of nodes without hurting our privacy properties.
Please drop us a link after the call to that paper. I would like to share it with the community.
Yeah, sure.
And also one quick additional note when it comes to node families. So an additional benefit of node families is going to be so we saw node impersonation by some node operators, which basically means that some people were trying to attract delegations by using well-known names such as Nodes Guru or other well-known node operators who have multiple nodes. And node families will sort of put a stop to that as well, because there will be this official way of larger operators who operate multiple nodes to say that, hey, these nodes belong to our family. So it also has that added benefit. Although the more important one is, of course, is making sure that no three nodes from one family are on layer 1, 2, and 3, and thereby having like a full path of packets all to themselves.
Yeah, so the other benefit that we get from this change as well is that nodes now we've instituted something that's good for security, which is that nodes are actually reshuffled every epoch so that they are in different layers as well. So that's something that helps things out there as well. So that's another benefit of the node families concept as well. So yep.
I dropped the paper that Dave was talking about in the community call text channel, so make sure to check it out if you're interested. And we have another small question. Do you still have time for it?
Yeah, sure.
All right, awesome. So this is from No Dump Node. Just a small question. So it's okay that some nodes of the same operator are only are on layer 1 and 2, but only critical if one is also on layer 3. So basically,
Yeah, basically the mixnet operates to protect its users as long as nobody can collude to de-anonymize traffic by checking all the way through the mixnet. So if there's one honest node in your path, you're good. That's the guarantees that the mixnet gives you. So yeah, that's what node families kind of enforces. It helps us achieve that basically.
And probably it's also worth mentioning that even if three nodes by the same operator are on the three different layers, even then it's not like they have like the entire route of every packet covered, because routes are always random. So they may have so the probability is there. So there's a non-zero probability for them to have the entire path of a few packets,
correct,
but not all of them.
But they're not even likely to like they're not going to know. In practical terms, you're not going to get very much even in that situation, because the likelihood is that it's not like it's different than Tor. In Tor, which is a circuit-based protocol, basically once you have three nodes that you've picked, you use those three the whole time for all of your communication. And think of it, you can think of that sort of being like a garden hose that goes between three locations with water kind of like pumping down it. It's like a circuit that is established, right? NIM is very different. So your client sends randomly by default through every node in the network. So it's not like you have the chances that you'll get like all of your communication going through three specific nodes that are controlled by somebody is zero. They're just not going to get that much information about you even in that case. But it's still good to insulate ourselves against that to whatever extent we can.
Of course. That's what the mixnet is about. Am I right?
Yep.
All right. Well, Dave, huge thanks for doing this, man. I'm sorry to inform you that I will have to have you back on, so I'll be pestering you about that nonstop.
Always a pleasure, Simon. It's always a pleasure.
By the time you are, I promise you, I'm going to figure out something for your amazing drawings to like with a little bit less clunky way to stream video.
Sorry about that. If we just so everybody knows, we did actually we religiously tested everything out beforehand. Everything was looking really good. We thought we had it all figured, but as soon as more than 25 people showed up, then it all fell apart for us. So we did try, but it didn't really work very well.
Yeah, unfortunately, Discord. Exactly. Yeah, next time we'll figure it out. Unfortunately, Discord is not the best platform for streaming video, but we'll figure something out for that. So, Dave, with that and 14 minutes over, I will let you go. Huge thanks for coming on, and I will say my closing thoughts, unless you have any closing thoughts.
No, go for it. It's all yours.
All right.
I'd just like to say thanks to all of our community. Basically, it's great. It's amazing to see this blossoming into what it's becoming. It's great. Love it.
I couldn't agree more. I absolutely love you guys. Huge thanks for coming on today, and I would like to wish a beautiful weekend to everybody. The call, as usual, was recorded. I will try to also put the video in of Dave drawing things, and at least the audio recording will be uploaded to the usual community call playlist. Now, one thing I need to note is that I owe you quite a few uploads. They are all downloaded on my machine, but I just didn't have the time to edit the videos and upload them. So hopefully during this weekend I can upload all the remaining community calls, and you can binge watch all of them if you want to see them again or hear them again, or just weren't able to make it to some of them. So as always, big thanks for coming on, and I'm going to hand over to Ismail, who will share the very simple instructions with you on how to claim your POAP for this community call. Have a lovely weekend, everybody.